we'll do some examples of electrolysis. Okay. First example. Electrolysis of molten or fused sodium chloride. Okay. No water is there. So sodium chloride will dissociate as Na plus and Cl. Now, what are the electrodes we take? Electrodes in laboratory, you can take platinum in laboratory and graphite in industry. Okay. So now, first you have to write cathode that we have already done this one. Anode. So conventionally you have to do cathode because cathode starts with positive and anode starts with negative. But we will do it first because what will happen? The chloride will go to the okay, it's a very crude one. This is the electrode. And I told you by convention, always cathode will be on the right and anode will be on the left. Okay, this is made up of platinum. Okay, and this will be connected, as I told you. This is the battery. Okay, so this is the switch. We call it T. You don't have to draw. When it's melted and when you switch it on, then this is the molten sodium chloride. So all the Cl minus will be here. They'll migrate towards anode, and all the Na plus will be here. Okay. Now this Cl will go to the anode. Moment it goes to the anode, this electron will be here. Electron will be here. This electron will be here. Okay. So here, what will happen now? Here, chloride is going to lose the electron on the anode, and we know chlorine atom is not stable, so it will give you Cl. Okay. So here you will find the Cl2 gas will be different. All right. Let me write here. Now this electron will now travel. And ultimately will reach here. Okay. This electron will come and all right. Then this sodium ion will take the electron. What will happen now? Na plus electron. Right now here. Sodium is a metal, so you'll find sodium will be deposited on the surface of the atom. So let me write that to just to balance it. This is the thing which happens here in case of. Now you draw it. Right. I'll give you 2-3 examples. After that, I'll go to the theory again. Aqueous. Aqueous solution of sodium chloride. Now, when you take aqueous sodium chloride, as sodium chloride will ionize, please remember water also undergo ionize. H plus and V. Okay. Now, how many cations you have here? You have Na plus aqueous, OH minus. Why do you write? Because it will be surrounded by water. Because ions in solutions are not stable. So it will be this and H plus anions. Anions will be chloride aqueous and hydroxide aqueous. Okay. Now the question is, which one will undergo, which one will discharge? Whether this will discharge or this will discharge. Okay. The differential discharge depends upon one, redox potential. That I will discuss with you later on. Redox potential. After finishing electrochemistry, then I'll go to redox. Higher the redox potential of the ion, better will be their discharge. So until unless I don't discuss redox potential, you will not understand. Second, over voltage. Their over voltage also I will discuss. Over voltage. The ions with lower over voltage undergo faster their theory. Please do correction here. You clear minus. will happen now? In cathode, and this is anode. So hydroxide will not lose electron, chloride will lose. Cl minus aqueous will give you chlorine and okay. Then Cl plus Cl will give you Cl. This electron will travel and come to the cathode. Between this and this is having higher reduction potential. So this I'll give you the whole table. Don't worry. So this is reduction potential is 0.00 volt. And this is minus. So between minus and 0 is higher. What will happen now? Yeah, 2H plus aqueous will take 2 electron and it will give you. So this and this will be at node. There will be liberation of fluorine, and the cathode there will be liberation of hydrogen. Now very interesting. See here. This is going out and this is going out. So what is left in the solution? The ions left in the solution is Na plus aqueous and OH aqueous. Okay. So solution will gradually will have more sodium ion and more hydroxide ion. So when they combine, what they will give you? Sodium ion. So this is the byproduct. Okay. This is the industrial preparation of sodium hydroxide, which you read in class 11. Kessner-Kellner process. So in Kessner-Kellner process, we use this method not to prepare hydrogen and chlorine, just to prepare sodium hydroxide. And in Kessner-Kellner process, mind it dear, hydrogen and chlorine are the very important byproduct. Now we'll go for hydrolysis of water. Please remember, pure water means what? Or distilled water does not conduct electricity. Means you cannot go for the electrolysis of pure water. However, the electrolysis of water is done by adding catalytic, means small amount of acid or base. If you begin what what will happen here? H plus or OH minus, this is being added. So it breaks down give you L. To give you H plus aqueous and OH minus aqueous. What electrode we take here? Electrode is platinum. Okay. So now cathode and so now see here. What is the anode here? Hydroxide. Anion is hydroxide. So it will give you plus 4 electrons. See here, from these all the 4 electrons. And example, now we'll go for a very important portion of electrolysis. We call it. What's the name of Faraday? Michael Faraday. Okay. Faraday's law of electrolysis. So there are two laws. Faraday's first amount of substance deposited or liberated at the electrode is directly proportional to the quantity of electricity passed through the electrical charge passed through the solution. Let W be the amount of substance liberated at the electron and Q is the amount of electrical charge passed to the solution. Then what will happen? W is proportional to E. But Q is equal to what? I into E. Where I is equal to what? Where I is equal to quantity of electricity in ampere and P is equal to time in second. Oh, I made a mistake. W is proportional to, or W is equal to Z into Q, where Z is the proportionality constant known as electrochemical therefore W is equal to Z into I into say this W is equal to Z into I into T is equation 1. If I is equal to 1 ampere and T is equal to 1 second, then what will happen? Z will be W will be Z into 1 ampere and 1 second. Therefore, so let me write the definition of, this is the way we always try to find out the definition of constant. So this is electrochemical equivalent. Thus, electrochemical equivalent may be defined as the amount of substance liberated at the electrode when 1 ampere of electricity is passed through a solution for 1 second. So sometimes this definition is asked. Z is equal to chemical equivalent divided by Coulomb, COLU. Now, what is chemical equivalent? See, I don't want to put any symbol because these symbols are not given in according to IUPAC. Yeah? So I will not put. But you can think that atomic mass is m, and if the charge is n, then I don't, because you may write in the exam, your teacher may not give you marks. So if it is m by n, then I can put here m by n. So it will come to what? Z is equal to m divided by n into 97,500. I'll do one numerical, then it will be clear. Calculate the amount of copper deposited at cathode when 5 ampere of electricity is passed through copper sulfate solution for an hour. Okay. Atomic mass of copper is 63.5 gram mole inverse. That is what first you will write here now. We know W is equal to Z into I into T. The moment you write, you get half mark. Now, what is I? I. What is T? 1 hour. Time always should be in second. So what should we do right now? 60 into 60 second. Equal to T. Now I have to calculate Z. See, what does it say? This chemical equivalent divided by what? 96,500. So I'll do it in a box. Z is equal to chemical equivalent by 96,500. Now, what is chemical equivalent? Atomic mass of copper, and second is what? Charge of copper. See, what is the charge of copper? Copper is what? Copper is CuSO4 dissociates as Cu2 plus and SO4 2 minus. So charge is 2. What is chemical equivalent now? Chemical equivalent is, what is the mass? 63.5. 63.5 divided by. Then what will be Z? Z will be equal to 63.5 divided by 2 by 96,500. So it is 63.5 divided by 2 into 96,500. Okay. Now, Noreen, calculate with calculator and tell me what is the value. 63.5. Do. Don't remain quiet. understand, then why you only tell 63.5 divided by 2 into 96,000. How much it comes?
3.29 into 10 to the power minus 4.
3.29 into 10 to the power minus 4. Okay. See, now you know W is equal to Z into I into T. All the values are there. This is for I, this is for T, and this is for Z. Do it now. Do. Who told me the answer? How much of electrical charge is required to obtain 1 mole of aluminum metal from 1 mole of aluminum ion? So let me write the equation. Aluminum has a charge of 3. I want to get aluminum. So this is Al3 plus and this aluminum is neutral. Then what should I do? How to make it neutral? Should I erase it with my hand? Tell. How to convert Al3 plus to Al? How?
Plus 3 electrons.
Very good. 3 electron means 3 negative charges. See here. It is 1. And this is 1. And this is what? I have to add here now. See. Where from suddenly you got 96,500? See. Charge carried by 1 mole of electron is 96,500 coulomb. But it is such a big number. So we have another unit called Faraday. 1 Faraday is equal to 96,500. Now where from you got it? We did not get the value in dream. See here. 1 mole is what? This. It is this much electron carries. Each electron carry how much? 1.66 into 10 to the power 19 electrostatic moment into 6.02 into 10 to the power 20. Don't write this one. Who will do the calculation? Gitanjali, what about do? Where got calculator? How would I? 1.66 though, right? 10 to the minus 19. Actually, it comes
So it's
in,
1.6.
huh? 1.6.
1.6 times.
So,
So 96320.
1.6 into 6.02. Yes. It comes to near about 96,400 something. Huh? And that is being, for simplicity, we make it 96,500. From there only that value has come. Okay. Now see. How much you require? 3 mole. So for 1 mole is this much. So therefore what? This is only for our information. Therefore, amount of electrical charge will be equal to what? How many you require? 3 mole. So 3 into 96,500. So find out the value.
So 289500.
So it is 289,500 column. Or what I can write? Or simply 3 Faraday. Hours. Does it take to reduce 3 moles of Fe3 plus iron to Fe2 plus? Okay. Now see here. So now, what is the problem? Fe3 plus iron to Fe2 plus. If you supply 1 mole, you become this. So if it is 3 mole, here also you require 3 to get 3. Okay. So what is the quantity of electrical charge? So here 1 quantity of electrical charge. See here, it's 3 mole, na? It will be what? 1 mole is how much? 96,500. So here it is 3 into 96,500. So get the value. Okay. Now what is electrical charge? Electrical charge, that is what? Q is equal to what? I into T. So what is the value here? Just now we have done 289,506. So here 289,500 equal to, see here. Oh, sorry. Wait. Sorry, dear. 2 ampere of 2 ampere of current. Sorry, huh? So it is 2 into T. So therefore T is equal to 289,500 divided by 2. Find out. And will be, see, T will come in second. It will be very large quantity. So convert into second. Sorry, convert into hour. Not second.
So it is 144,750 seconds.
See, this is a very large quantity in second. This T in second or not? Whatever value you have found, T is in second. So as it is very large quantity, convert into hour.
So
how?
40.2 hours.
Huh?
40.2.
Very good.
Done, sir.
Yes. Wait, I'm trying to find some other problem. Electric charge is equal to reduce 1 mole of Cr2O7 minus 2 Cr3 plus. Cr2O7 2 minus. This affliction charge is what? 7. Sorry, 6. And you are supposed to get Cr3. See, plus 6 is coming into plus 3. 2 chromium, so I have to write 2 chromium. Each chromium has taken how many electrons? 6 electrons. And it is done in acidic medium. So we'll write now here 14H plus. Try to remember in your class 11 days. Okay, so it is 1 mole. And how many moles are here? 6 moles. And so find out how much electricity is being associated with 6 moles of electron. Fine. This some seems to be scary, but you can do in one line. Yes. Good girl. What do you say in Khasi? Good girl? First, I'll explain this experiment. This is very important because this is being done in electroplating. Okay, suppose say you want to have a dinner set made of silver. So if you go for pure silver, it is very costly. So what we can do? We can buy a dinner set made of copper. And we'll go for electroplating. See, so say this is a, they have made a silver plate. Huh? Okay, now see. Say this is the plate. This is a silver. Sorry, not the silver plate. This is the metal. Okay. And here I'll take a electrode made of, this is cathode, this will be cathode. Okay, metal plate. Okay. And this is the anode. And this is made of pure silver. And here electrolyte is silver nitrate. See, here we are taking an active electrode. This silver nitrate. Okay. Now, let me remove. So cathode and oh, sorry. Yes, cathode on the left cathode, and this is here you will see here nitrate will not go there because you want to convert silver ion to silver. Okay, so electron. Then who is going to supply electron? In active electrode, electron will not come from the anion and the electrolyte. It will come from here. So this is the pure silver that you have taken now. Pure silver. This pure silver will give you the electron. This is the electron which will come. So, okay. So this is the battery. So it will be like this. So it says that how you want to coat it with this much thickness. The same way you are getting gold-plated ornaments. In gold-plated ornaments, what they do? They put the ornament made of silver here. Okay, and instead of silver, they will take pure gold, and here they will take gold salt. All right. Now the gold from gold salt will go and deposit, and the gold from here will go to the solution. See, this is going to the solution. All right. So how much they want? This is the thickness. Okay. The surface area is 80 centimeters. So we know the equation is what? W is equal to Z into I into T. See, here they have given only I and nothing else. In a single equation, you can find the value of only one. Other value must be provided. See here. Here I is being given how much? 3m. And time they ask you to find. Okay? W you do not know. So how it is possible? If you don't know two things, then how can you find? Huh? Z I can find. So I'll write here again. Atomic mass of silver is 108 gram mole. So Z I know. What I'll do? 108. 96,500. See, what is the charge on silver? See here. 1 only. So that value we will find it. So W we do not know. Okay. So now we have learned. What is the cross section? Cross section of metal plate is 80 cm square. What is the thickness you wanted? thickness of silver is what? 0.005 millimeter. So is equal to how many centimeters? How many? I have to convert. So is equal to what? 0.0005 centimeter. All right. I have to find W from there. It's not magic. Simple thing. See here. We know cross section into thickness is equal to what? Volume. Okay. Now we know density is equal to mass by volume. See, volume is, so volume, so you know, volume is equal to what? 80 cm square into 0.005 cm. How much it comes? I'm eating it. How much it comes?
Zero point zero four.
0.04 centimeter cube. Okay, now mass I will find. It is D equal to W by D. So therefore W is equal to what? D into V. All right. So density is given 10.5 gram centimeter cube. And this is 0.04 centimeter cube. So how much it comes? It comes to
0.42.
0.42 gram. Now understood? What is this now? 0.42 gram. So put all these values in the equation and find W. So now we know that G, okay, again, right? W is equal to Z into I into T. So 0.42 is equal to Z is equal to 108 divided by 96,500. This is 3 and this is T. Find out. Therefore, T is equal to 1. Fine.
Sir, I got 125.09.
One what?
125.
Point
0.09.
Yes. What? Second or minute or hour?
Seconds.
Yes. Second lot I did not do. Anyway, at least you have done some sum. Others you will not do.